Well, I'm not here as an expert in any part of AGI, although I've done a little bit of natural language processing research. I'm here as an expert in virtual worlds. And since that's not perhaps a typical topic, at a conference such as this, I'm going to give very short, 2-minute, my own points on why I think this should now be a chronic session.
Sibley, you got 3 minutes.
This conference. I'll try to beat your 3 minutes. All right. I think there's 3 great reasons. One has already been mentioned, embodiment, but I think the virtual worlds that are growing up out there today that literally have millions of very active and creative users, it's qualitatively a different type of embodiment than we get from the toy worlds that have been used for decades for AI experiments, and even compared to robotics, given the limitations to perception on the robots that we have today. What we have is an extremely complex and undefined and unpredictable virtual environment that consumers are in, and that is a great test bed for AGI over more limited AI for obvious reasons. Secondly, I think that we also, by virtue of having millions of users, we've got a great, we can provide these users with the incentive to give feedback to virtual agents in a way where not only are they providing feedback to help the learning process, but they're even defining what should be learned. So I think in that way, while the virtual world is not necessarily a mirror world, it won't teach an AI all things about the physical world, it will teach many common sense elements and many things about dealing with humans and characters and some things that are analogous to the real world, and that we can provide an incentive for all these users through, whether it's games or training or education, to perform that learning. It's something that will help, I think, some processes in creating AGI scale up. Lastly, and perhaps most importantly, I think this is part of the reason I got into virtual worlds in a way, is that I think as you look out into the world today, I think they provide, that's the industry that provides the most answer to the funding question that was brought up yesterday. I don't think we're going to have a government Manhattan Project for this anytime soon, but what we do have is a multi-billion-dollar industry that is looking for more ways to engage and entertain paying users, paying government agencies who want to run training simulations, etc. And they're looking for all kinds of ways to enhance their products. And AGI can absolutely, and I think even over niche AI, can provide compelling products. And if anybody wants to talk to me more about that, I'd love to chat more about that at other times. So I think that is a way to relate the research goals of this group to things that will have dollars put into it. So with that, we've got 3 good examples of early stage experiments and exploration of how to use virtual worlds in AGI research.
Okay, another one for Ben. You had this cat chasing behavior in your dog as an alternative goal structure, and I wondered, what are your goal primitives? How do you encode different action tendencies in the system, and how does it scale up?
Right. Well, there's actually a paper on that on the novamente.net website, which I'm giving at the AISB conference in April. But in short, the dogs have a certain set of goals, which is the high-level goals are programmed in. Pleasing the user is one, and then the others are allied with the emotional structure of the dog. So it can be get happiness, exert aggression, and so forth. And the weight of the different emotions is different for the different dogs. It's personality makeup. Then there's the dog has associated with it a set of logical rules, which is executed by the PLN inference engine. Actually, it's like if I am feeling aggressive and there's someone near me and they're not my friend, then I bite them, then I'll be happy, and so forth. So this set of logical rules, which in the current system it is hard-coded, but the architecture is consistent with having them learned as well. This set of logical rules is combined through forward and backward chaining to figure out what to do based on the goals and the emotional state and personality parameters in the dog. So that's a little bit of mini probabilistic logic engine governing the behavior in there, actually.
Let's take the question back.
See?
Yeah.
Thanks. Okay, my name is Simon Levy, and most of what I do here at Encoding is teach AI undergraduates, and I think this stuff is not only the future of research, but also the future of teaching and learning in AI. So my very practical question to Ben and anyone else who gets the answer is, what do you think about the availability of APIs for doing this stuff? Like if I just wanted to get into Second Life hacking, hack avatars, I mean, you know, at a non-trivial level, so I have to get some licensing agreement with them because I've had very mixed experiences dealing with companies.
You don't need a licensing agreement. I think working, I mean, Second Life it's not open source, but anyone can put scripts up there. And my experience working with Second Life is that it's kind of complex and the APIs are difficult to work with. But we're planning this summer to open source our API for interfacing AIs with the multiverse engine. And I think that something similar can be done with OpenSim, although we haven't gotten there yet. So
there's quite a few, I'd love to add, there's quite a few virtual world technologies out there where you can put content and connect other software to either your own instance of the virtual world that you run yourself, and you have the intellectual property ownership of whatever content or software you're adding. And that's true of Second Life. The only reason really to use Second Life is if you want to expose to its user base or its content creation tools, but it is harder to interface other software with than some of the other choices you have if you want to just play in your own sandbox. But the legal regime is pretty friendly, actually, with a lot of these. You have to hit the button again if you're done. Yeah.
Oh, hello. I have a question for Martin. I was wondering how you keep your computation time from exploding when the knowledge base size increases.
Yeah. That's a very interesting future research topic.
Well, I think there are ways to do it.
Yeah, there are simple approaches that might work. I haven't gotten so far that I have tried them out yet. But for example, just dropping the oldest data might work, because when these characters walk around, they achieve more and more presets, and the inference engine will slow down because it has to search through the entire database. So just dropping off old things would be one of the first things I'll try soon. But it's not certain that this will work. It's probably a really hard problem in general. So
yeah, this is what we use a sort of economics-based attention allocation mechanism for. So we have short-term importance and a long-term importance associated with each item. So in your system, if you had the sort of long-term importance number associated with each term or relationship, those would decay over time. So you would, in general, forget the oldest items. But if something seemed particularly important for some reason, that could get its long-term importance boosted. So like I still remember my mother's middle name, although it's old and hasn't been useful to me for a long time.
And also general knowledge about actions.
Right.
So the characters had knowledge about the actions about, say, buying and selling things, and that's part of the oldest knowledge they have.
And you don't want to. Yeah, your oldest knowledge is like
you don't want to forget
that you exist. You don't want to forget that, even though you learned it when you were 6 months old.
Right. But you also talked about indexing on space, for example.
Mm-hmm.
So I guess if you move to the same location where you were previously, maybe you could increase the importance of that part of the knowledge base, the preset you learn.
Well, you might also consider association, that is, to look for things that are associated with the current input. Like the LIDA model uses neural semantic network so that the inputs can excite similar nodes and only reason about the things that have been excited in the cycle.
Right. There's the issue of how this would integrate with planning.
Well, you would basically be pulling part of your knowledge base and reinstantiating it in workspace so that you would only look at the current context and reason about that instead of the whole knowledge base.
Yeah. But there's a problem if you try to achieve complex goals. You might not know beforehand what part of the knowledge base you want to use before you actually find a plan for how to achieve the goal. So if it's not obvious from the goal that I will need to do these actions and know this, have this knowledge about the world, then it's begging the question to say that we should just load up the relevant knowledge because we don't know what's relevant before we have actually found it.
Yeah, you need other mechanisms as well.
Yeah.
I actually have a question for you at some point, Sibley. We don't need to preempt it right
Okay.
now, but I know before you got into virtual worlds, your previous company was in the area of natural language processing. I'm curious for you to share your thoughts on the value that virtual worlds might have for moving to a more and more powerful natural language processing.
Well, I think there's could be a lot of details to that, but I agree with the paradigm that we're generally presenting and here, which is that I think having AI systems with some ability already set up, interacting with humans, with just all kinds of users who are out there who are very tolerant of the AGI only having so much knowledge and making certain kinds of mistakes, which certainly you would for talking pets, I think, and many other characters in this environment. I think that will really help because it's somewhere in between the coding all the manual rules and the completely automated. It's supervised learning. I think a really huge fishbowl full of supervised learning where the supervisors are doing it for their own reasons of entertainment or other economic advancement. I think it's going to be the way to bootstrap to a lot of common sense knowledge in a knowledge base, as well as getting over the surface level, a lot of the surface level NLP issues.
So when you were doing practical NLP work, what were the biggest obstacles that you saw in terms of the narrow AI NLP not doing what it really
word synthesis and disambiguation. I mean, really, NLP is, of course, a collection of quite difficult problems, and the real problem is getting all these error-prone processes to work well together, whether it is from the parsing, through other things. But I think that whole set of problems that we have messy algorithms for that make mistakes would all be a lot easier to get work well in concert if the actual symbols that we're operating over in trying to learn from Wikipedia or whatever it is were not ambiguous. And it's just ridiculous that not only do we have the synonyms, but the actual, it's kind of non-deterministic when you see an actual symbol. So I think then, because then you have to get into context and everything. So I think that's the messiest piece of the whole thing. And I would hope we could induce users to help tease out some of the relevant contextual information needed to crack that better.
Yeah.
They have been, and I'm going to go back to the next one.
I'm just waiting for them to finish.
Great.
Okay. As I mentioned to a number of you, I'm currently kind of taking a sidestep away from the Joshua Blue work to work on multi-core programming, and especially looking at massive multi-core systems that are coming in a few years. The application that we've chosen to help drive that relook at the software stack is what I call a 100x virtual world. And that's what I'm interested in hearing from each of the panelists, given that you found value in working in virtual worlds, is if you could pump up any characteristic of a virtual world, whether it be number of avatars, physics, whatever you want, by a couple orders of magnitude, what would you choose? What would you like best?
Well, from our point of view, right now, the strength of existing virtual worlds is really in the just contextual social interaction. But the level of control over the body is not what you would like to get kind of realistic sensory motor activity. And that's partly a matter of computer hardware issues and partly a matter of the way the software frameworks have evolved to adapt to the computer hardware. So just making better processors isn't going to solve it. The thing is, the way you build a 3D model now, setting aside Second Life, the way you do it in most 3D virtual world platforms, you use Maya or 3ds Max, you make wire mesh models, you make animations to carry out certain motions, or you do a kind of hacky combination of inverse kinematics with animations. And none of this stuff is that much like controlling a human body. But the reason you use these kinds of abstract methods is twofold. One, it's easier for the human beings creating the movements, but the other is just getting movements and animation to work in real time on current processors is hard. So I think that if you had more realistic movement and feeling, that would require two things. It would require awesome hardware, and it would require a whole new generation of software for creating these
things. Both of those. That's why I'm asking the question: is what's the
physics is a whole other thing. I mean, you talk about you want to make a robot to mop your floor. You can't teach it to do that in Second Life, Multiverse, or OpenSim, or anything out there, because fluids and dirt and hair on the floor and stuff just don't work the way that you think they should. If you want to do kind of Piaget's basic conservation law stuff, you can't go in Second Life, take a hunk of Play-Doh, roll it out into a tube and say, well, that has the same amount of stuff as when it was in a ball, because Play-Doh doesn't work there, right? And how important this is for AGI isn't totally clear. You may not need that stuff. It may be just being able to ground relations and objects in the world and interact socially in a shared environment where, as he was saying, you see the other guy, he sees you, and you build that network of relations. It may be that that's enough. On the other hand, it could be that our ability to understand the world is based on metaphors, all this low-level sensory motor learning and pattern recognition. And you really need that richness, where each time you do something slightly different to the world reacts in a slightly different way. So I feel like in the real world, learning to do things, you have more of a kind of fractal fitness landscape in terms of how you get response to what you do. Whereas in a virtual world as it is now, there's not that much subtlety to the fitness landscape for behaviors. So you really had two. You had sensory motor fidelity, in a sense, and then physics fidelity. Right. I'm not sure that fidelity is necessary. Although that is probably the route it'll take. I would say the richness of the physics, the richness of detail, so that doing different things leads to different responses, and doing different things in a patterned way leads to responses that differ in a similarly patterned way. Probably the easiest way to do that is to give fidelity, but it wouldn't have to be fidelity. It could be some alternate, equally rich and complex reality. Right?
What about the rest of it?
Well, I think that for the purposes of our research, the first point that was made would probably be the most important for us. The finer motor skills, since we're primarily interested in modeling human cognition, not just in one artificial agent, but being able to capture cognition that's occurring in not necessarily an artificial agent, but perhaps a human behind an avatar. It's vitally important to capture as many features as you can in the behavior that avatar is exhibiting.
Okay.
Well, I can suggest another thing, because as we were saying, it might be necessary to have a high-fidelity physics simulation, for example, and high-fidelity animation, but it's not for sure that it's necessary.
Right.
But what we do know for sure is reasoning about other agents' mental states is really complex, and also planning, and that's two things that humans are maybe not perfect at, but they can do it, and they do it all the time, especially in natural language understanding and in social relationships. And the theorem proving steps, it gets really complicated. But still, if you try to introspect or look at what humans do, it is actually complex reasoning. So it's not sure that that logic is the wrong way to do it. It is complex, but we are so good at it. But if we could put more processing power into the theorem prover, is my suggestion.
Well, there'll be plenty of, I mean, our current platform is looking at like 2.7 teraops per second. So there's plenty of cycles to go around. If you can figure out how to do it on massive multi-core systems.
Yeah, your comment reminded me of one more thing, which is just talking about recognizing people's emotions and expressions and kind of social interactions. There's such a strong extent to
create these applications and allow millions of people to use them. But I think we already have so much complexity that when I go into a virtual world, I'm not using all of my knowledge about the real world, but clearly performing activities that require a lot of intelligence and that teach a lot of knowledge to me, that I learned from my experiences there. And so I think that complexity in learning is sufficient already.
Thank you.
A question to Ben. Do you hear me?
Yeah.
What is your approach to implementation of emotions, and in particular, how do you represent an emotional state, and how do you recognize or decide in what emotional state should that be?
Right. Well, the first thing, as I just said, I'm not very happy with the separation of emotion from kind of embodied gesture, which is enforced on us by the way the current virtual worlds work. But within that framework, that gets a bit into Novamente's knowledge representation. But we have a number of atomic emotions, which is based on a book by Ortoni and someone else called The Cognitive Structure of Emotions, where they break down emotions into sort of logical ontology. Not to say that I necessarily buy their theory of human emotion, but it's a nice guide for a kind of logic-based implementation of emotions. So we have atoms in our atom table, our knowledge representation, which are predicates corresponding to individual emotions. But it's a little subtler than that, because in Novamente, there's sort of two levels of knowledge representation. You have knowledge represented as a single node or link, but then that node or link leads to a pattern of activity across the whole node and link network. So you can say the emotion is represented by a single predicate node, say joy, anger, but then that single predicate node is associated with something kind of like in the attractor neural net, a whole network of other nodes and links that are engaged in activity when that predicate node is activated. So we started with a logical theory of emotion, you put in Novamente, and then it becomes a kind of nonlinear attractor implementation of emotion.
Oh, okay, thank you. But what do you think about higher order emotions, like shame, pride?
If you look at Ortoni's book, actually, they give a very nice reduction of those to logical combinations of simpler emotions, which, as I said, I'm not going to defend or argue against as an accurate theory of human emotion, but has been quite convenient for implementing a simulation thereof.
And what about the ability to attribute emotional states?
The ability to what?
To attribute emotional states to other agents.
We have not actually done that yet in the virtual dogs. So they don't attribute emotional states to other agents at this moment. That really requires theory of mind. It requires self-modeling. And in the approach that we're taking, that's going to be a little slower than in the approach of Andrew Summer and their team. Because in our approach, the theory of mind really has to be learned. So it has to interact with the other agents and watch what they do. And then it has to learn that the other agents are sort of like it. And then it will, by inference, transfer its knowledge about itself to its knowledge about others. In theory, we haven't demonstrated this yet. I mean, you could wire in theory of mind into Novamente's logic engine in a somewhat similar way to what they've done. But I have a feeling that's not going to give you a theory of mind that's really robust, flexible, and generalizable. So we'd like that to be learned rather than coded in. We'll see if it works or not. Report back next year.
I'm curious if you want to respond to that at all. Your paper was pretty emphatic about the need to encode, or at least part of the theory of mind as opposed to learning.
Yeah, well, there are, I mean, I'm not intimately familiar with the structure of Novamente, but if you want a theory of mind to emerge, at one point you're tracking facts, and at some point you need to make a paradigm shift in the way that your knowledge is represented. You have to, your facts are no longer just facts, they are facts that you believe, or they're facts that someone else believes. And well, I'd love to hear your response to that, but at least in that, if that's the case, then there will be a severe issue with trying to evolve the theory of mind where your system has to change its representation.
No, I understand. I guess these kinds of discussions are hard because we're not at such a really low level of detail. These are such nitty-gritty issues. So as it happens, in our representation language, our vocabulary of nodes and links, we do have a concept of the contextuality of a belief. So you can explicitly say, like, in the context of this relationship holds. In this other context, this other relationship holds. The question then becomes one of context formation. So what the system has to learn is not how to contextualize beliefs. It has to learn to associate a context with another person. So it doesn't have to learn a new representation language, but just a new use of the existing representation language. It's still hard, but it's not as hard as you may have been thinking.
In that case, I'd say that we're not that far different. So
we're just about out of time, so we'll go ahead and take one more question.
Okay, so by the way, just in context of that, I think theory of mind in humans is basically instructed into them in examples like bedtime stories and fiction. I think that's all about. But I had a different question, which is for Andrew and maybe Martin might be interested to take a crack also. It seems to me that the white hat problem is something that maybe one person in 100 could actually solve, and that would be a person who had been instructed in that in a computer science class or thereabouts, or had done some of the problems. And that, in my experience, most people don't even have, really a large fraction of the population can't even think about how other people are going to react to their emails before they send them. So, I mean, people are very good at some things. Face-to-face communication, they pick up on some stuff, and it's important to some extent in language. But very few people think about second-order things at all. I think that's really quite rare, and third order is just not really feasible. Even in a poker game, people who try and do it are just going to fool themselves. So I'm curious why you think that's important for a human-level AI.
Well, to your first point, I would just mention a variation of the experiment where if the wise men are not able to figure out what color hat they are wearing, then they're immediately killed. And I think in that situation, you might find that I don't know about conducting an experiment there, but they might be more willing to.
I really don't think so. And if you told me, if you pointed a gun at somebody's head and told them to solve a 5-person problem or he's dead, most people are going to die. People walk into job interviews and get these questions all the time, and they really are motivated, but they don't get them right unless they've seen something like that. So you're testing whether the person's seen that.
And we do have a long tradition in logic-based AI of choosing problems that are particularly difficult. But to your second point, well, actually, I need to think about how to respond. Can you repeat the second part of your question?
The second part is, more generally, I think that, you had a slide up there about how I have to know what you believe about what I believe. I really don't believe very many people.
Okay. I just don't think he's
so,
right about
yeah,
psychology.
I wouldn't agree with that either. I think that we may not be aware of it, and we may not be able to necessarily formalize everything that we're doing in every case. But I think that we actually are performing quite a good deal of reasoning about each other's beliefs. When you made a joke earlier, you anticipated that the people here would find it funny. You had to be ascribing some default beliefs about your own belief set to everyone else.
One reason I'm skeptical about this is because some people, like my wife, for example, is really much better at predicting political things in her office and stuff than I would just, would just pass right over my head. And most of the people in this room, I suspect, would pass over their head. And I'm not particularly bad, I'm certainly not very good. So when you see somebody who's so much better, and yet sometimes you see her, I can see her talking to somebody, and I'll see that they haven't understood and she hasn't appreciated it. That happens all the time, so there's some way she's thinking about it that's different, but it's not necessarily always superior.
Can I add?
Yeah, go ahead. Go ahead.
Even if most people might not be able to solve the 3 wise men problem, if you explain the solution to them, you can get them to understand it. And the reason it's hard to solve is not that they don't have an epistemic logic that is capable of representing it. It might be that it's hard to find the proof or the solution, and it's a search problem. So it's just that they would be able to find it, just that it takes a long time. And if you explain the solution to them, they understand it, and this shows that they have the same capability.
I think that's
I would actually
true.
be interested in data on whether, if you picked a 110 IQ person who hasn't any computer science background and tried them to explain to them the solution to the 5-person white hat problem,
But this
you can get them to understand that, you know,
it's completely the wrong direction, though, Eric. I think I agree the average person can't solve that very well, but if you look into psychology literature more generally, you just find that people's cognitive ability is not that general. And in domains that we're attuned for, we do a really good job. So I mean, people may do badly at that, but if you take the average Latino female, for example, and just I happen to be married to one, and give them a logic puzzle involving who's cheating on whose husband with who, and who knows about it, and who knows about it, and they can go 10 levels deep. And that's very subtle reasoning, and we're good at that. We're just not attuned to these kind of logic puzzles.
But it's not a general purpose thing. We've got specific, that's exactly
well, we're better, it's better tuned for some domains than others. So this becomes a subtle question, then. Do we have a special purpose mechanism for saying who's cheating on who? Or do we have a general purpose social modeling mechanism which is just better parameter tuned and better linked into our intuitions in some domains than others? I guess my guess and Selmer's guess would be the latter. Maybe your guess is the former.
Also, is John Laird still in the room? He might have a comment on that, about context-independent reasoning versus context-dependent reasoning. Yeah, it's absolutely true. I mean, these sort of puzzles, when they're taken out of context, when they're abstract, they're very difficult, and that's sort of you know, intelligence analysts, they're probably pretty good at that sort of problem, but the general population, they're not. But when there is context behind it, you may find that they can be solved.
Well, we're at least as late as we were when we started, so we're going to close out, and I'll add a final thought that I was thinking when I was watching these presentations, that while we may disagree on some of these small issues, I really hope we all agree that we can't afford to let Andy's evil avatars talk to Ron Arkin's ethical soldiers.